We have already discussed the stepping stone method, which we said is heavily reliant on your visual skills. So I will now be discussing another optimization technique that you can choose from, which rely more on your mathematical skills. And this is the modified distribution method. The modified distribution method is a streamlined version of the simplex method that takes advantage of the special mathematical structure of the transportation model. One advantage of the MODI over the simplex method is that it does not require the use of slack or artificial variables to get a starting feasible solution. In the regular simplex method, cost-reducing variables are recognized by having a negative C sub j minus Z sub j value. The same C sub j minus Z sub j indicators are used in the MODI method but are calculated in a much easier way. So what are the steps involved in modified distribution method? Similar to the stepping stone method, the first step is to generate a starting feasible solution by using your preferred heuristic. And you also have to make sure that the starting feasible solution contains m plus n minus 1 basic or used cells. Similar to your stepping stone method, if the pattern you got using your heuristic does not comply with the m plus n minus 1 requirement, then this particular technique would also not work. Assuming you already got your initial pattern that complies with m plus n minus 1 requirement, step 2 would be to assign row and column indicators to each row and column of the transportation tableau, whereby in general, for an m by n transportation problem, let r sub I represent the indicator value assigned to row I, and let k sub j represent the indicator value assigned to column j. Let us first make the two steps. Let me now begin with the row minimum method. If you would recall, in the row minimum method, we're supposed to analyze your tableau one row at a time, beginning with the topmost row, or in this case, the row of Cavite. And again, focusing on the least cost per row. So looking at the cells in the row of Cavite, our least cost cell is the one with the cost of 8. How many units can we allocate to that cell? It would now be a choice between the supply of Cavite, which is 50, and the demand of Baguio, which is 90. And we choose the lower value, which is 50. With that, we have depleted the total supply of Cavite, so we now eliminate the remaining cells in that row. And then we now reduce the demand of Baguio by 50. So from 90, it goes down to 40. Now in the row minimum method, if you would recall, even though there are remaining cells in the row that we have just analyzed, you have to move your analysis to the next row. In this case, since we have eliminated the entire row of Cavite, then we have no choice but to move on to the next row, which is the row of Laguna. Repeating the process. From the cells in the row of Laguna, our least cost cell is now the one with the cost of 5. How many units do we now allocate to that cell? It's now a choice between the supply of Laguna, which is 80, versus the demand of Davao, which is 40. We again choose the lower value, which is 40. And with that, we have met already the demand of Davao, so we can eliminate the remaining cell in that column. And then we now reduce the supply of Laguna by 40. So from 80, it goes down to 40. As I mentioned, even though there are remaining cells in the row that we have just analyzed, we have to move our analysis to the next row. So let's now move our focus to the row of Batangas. From the remaining cells in the row of Batangas, our least cost cell is now the one with the cost of 7. How many units can we allocate to that cell? It would now be a choice between the supply of Batangas, which is at 120, versus the demand of Iloilo, which is 50. So we choose the lower value, which is 50. And with that, we have already met the total demand of Iloilo. And we can now eliminate the remaining cell in that column. After which, we now reduce the supply of Batangas by 50. So from 120, it goes down to 70. Then again, even though there are remaining cells in the row of Batangas, we now move on to the next available row, which is the row of Laguna. From the remaining cells in the row of Laguna, our least cost cell is now the one with the cost of 7. How many units can we allocate to that cell? It's now a choice between the remaining supply of Laguna, which is 40, and the demand of Cebu, which is 70. We choose again the lower value, which is 40. With that, we have already depleted the total supply of Laguna, so we can now eliminate the remaining cell in that row. And then we now reduce the demand of Cebu by 40. So from 70, it goes down to 30. Then moving on to the remaining cells in the row of Batangas. Our least cost cell this time is the one with the cost of 10. How many units can we now allocate to that cell? It's now a choice between the remaining supply of Batangas, which is 70, and the demand of Cebu, which is 30. And we now choose the value 30. That would enable us to meet the total demand of Cebu. And then we now have to reduce the supply of Batangas, this time by 30. So from 70, it goes down to 40. And since our assumption in this example is where your total supply is equal to your total demand, then the last cell should be able to satisfy both the remaining supply and demand values, which in this case is equal to your 40. So this is now the shipping pattern generated using the row minimum method. Is this pattern compliant with the m plus n minus 1 rule? To recall, the m plus n minus 1 rule requires that our used cells, or those where there are shipping values assigned to them, should be equal to the number of your suppliers plus the number of your demand points minus 1. Since there are 3 suppliers and there are 4 demand points, that gives us 7 minus 1 is 6. There should be 6 used cells. And looking at the cells where we have shipping values assigned to them, we do have 6 used cells. Therefore, this pattern generated using your row minimum method is compliant with the m plus n minus 1 rule. So we now move on to the second step, which is to assign row and column indicators to each row and to each column. So for the row of Cavite, we would now assign it the indicator R sub 1. For the row of Laguna, you have R sub 2, and for the row of Batangas, it would be R sub 3. Moving now to each column. For the column of Baguio, we assign it the indicator K sub 1, followed by K sub 2 for the column of Cebu, and then you have K sub 3 and K sub 4 for the columns of Davao and Iloilo respectively. You might be wondering, why is it that for the rows we made use of the letter R, while for the columns we are using the letter K? It is not because we are using the Tagalog version of the word column. We are using the letter K instead of the letter C because the letter C has already been used to represent cost. C sub I sub j is the cost of shipping from source I to destination j. So to differentiate, we are now using another letter which is closest to the letter C, which is the letter K, to represent the indicator used for each column. With that, let's now move on to the next steps. Step 3. We are now to compute values for the R sub I and K sub j indicators using the formula R sub I plus K sub j equal to C sub I sub j as our guide, and this formula is used whenever X sub I sub j is greater than 0. In the formula, C sub I sub j is your per unit transportation cost, while X sub I sub j represents the shipment from source I to destination j. So, the condition X sub I sub j should be greater than 0 implies that this particular step is going to be applied to your used cells whenever there are shipping values assigned to a particular cell. After which, step 4 says, solve the resulting m plus n equations by setting R sub 1 equal to 0 and back substituting for the remaining R sub I and K sub j values. The process of back substitution is an algebraic process, which I hope you can still recall. Let's now perform steps 3 and 4. Again, we began with the row minimum method. So let's go back to our pattern. So we are now at step 3, wherein we are supposed to follow the formula R sub I plus K sub j is equal to C sub I sub j, and apply such formula for our used cells, or those where we have shipping values assigned to them. Again, you can apply the formula in whatever sequence of used cells you would like to analyze, because you are bound to analyze each and every used cell anyway. What I am using here is left to right, top to bottom. So I'll begin with the used cell in the row of Cavite with a cost of 8. The row position of that used cell is at row 1, represented by the row indicator R sub 1. The column position of that used cell is at column 1, represented by the column indicator K sub 1. So, applying the formula as our pattern, then you have R sub 1 plus K sub 1 is equal to the cost, which is 8. Next, used cell, the one with a cost of 7, which is at the row of Laguna. The row position of that used cell is at row 2. The column position is at column 2. So applying the pattern, the resulting equation will be R sub 2 plus K sub 2 equal to 7. Next, used cell, the one with a cost of 5, still at the row of Laguna. Row position of that used cell is now at row 2. Column position is at column 3. So the resulting equation based on the pattern is R sub 2 plus K sub 3 equal to 5. Next, used cell, the one with the cost of 14. I am now at the row of Batangas. The row position of that used cell is at row 3. Column position is at column 1. Applying the pattern, the resulting equation would be R sub 3 plus K sub 1 equal to 14. Next is the used cell with a cost of 10. Row position is still at row 3. Column position is now at column 2. So the resulting equation would be R sub 3 plus K sub 2 equal to 10. Next is the last used cell, the one with a cost of 7. Row position is still at row 3. Column position is now at column 4. Applying the pattern, the resulting equation would be R sub 3 plus K sub 4 equal to 7. We are now at step 4, which says we are now supposed to determine the values of your row and column indicators. We begin the process by first assuming a value of 0 for your R sub 1, always. Then we perform the process of back substitution, which is an algebraic process. Okay? For the equations that we created at the left side of the screen, I would refer to them as the first equation, the second equation, the third, the fourth, the fifth, and the sixth equation respectively. So let's now perform the process of back substitution. If R sub 1 is equal to 0, for the first equation to be true, then K sub 1 should be equal to 8. If K sub 1 is equal to 8, for the fourth equation to be true, then R sub 3 should be equal to 6. If R sub 3 is equal to 6, for the fifth equation to be true, then K sub 2 should be equal to 4. Again, if R sub 3 is equal to 6, for the sixth equation to be true, then K sub 4 should be equal to 1. Earlier, we found K sub 2 to be equal to 4. So, if K sub 2 is equal to 4, for the second equation to be true, then R sub 2 should be equal to 3. And finally, if R sub 2 is equal to 3, for the third equation to be true, then K sub 3 should be equal to 2. The process of back substitution, which I hope you still recall. The values that you're going to generate for your row and column indicators can either be positive, negative, or 0. So it depends on the equations that you are going to come up with based on step number 3. So once you have determined the values of your row and column indicators, then you just write them down on your tableau. Then we proceed to the next steps. Step 5. Calculate the opportunity costs of increasing shipments through each non-basic or unused cell using the formula C sub I sub j minus the quantity R sub I plus K sub j equal to your opportunity cost for non-basic cell ij. So, this particular formula would now be applied to our unused cells. And then, step 6, select the non-basic cell with the most negative opportunity cost. That is assuming that you have more than one non-basic or unused cell with a negative opportunity cost. And if no non-basic cell has a negative C sub I sub j minus the quantity R sub I plus K sub j value, then stop. The solution is already deemed optimal. Let's apply steps 5 and 6. Going back to our row minimum method. This time, we now have to shift our focus to our unused cells and use the formula C sub I sub j minus the quantity R sub I plus K sub j equal to your opportunity cost. Again, you can analyze your unused cells in any sequence you would like because you're bound to evaluate each and every unused cell anyway. I am still going to use left to right, top to bottom. I'll now begin with the unused cell with a cost of 9. The unused cell with a cost of 9 is located in row 1, where R sub 1 is equal to 0. And it's also located at column 2, where K sub 2 is equal to 4. So applying the formula, you have 9 minus the quantity 0 plus 4, or 9 minus 4 is positive 5. That plus 5 opportunity cost is now what would be added to the cost if ever you intend to ship 1 unit of supply from Cavite going to Cebu, which is the same interpretation as what we had when we were discussing improvement indices in the stepping stone method. In fact, let me marry the two processes. So again, focusing on the unused cell with a cost of 9. If you are now to use the stepping stone method, then that means you now have to trace the closed path of that particular unused cell, which in this case would be from 9, you go down to the used cell with a cost of 10. Then you go left to the used cell with a cost of 14. Then you go up to the used cell with a cost of 8, back to our unused cell with a cost of 9. After which, you assign your alternating symbols, beginning with a positive symbol on the unused cell that you are evaluating. So applying that, you would have plus 9 minus 10 is negative 1, plus 14 is positive 13, minus 8 is positive 5. The same as what we got as our opportunity cost. Okay? So, let's now proceed with the other unused cells. So this one is mathematical in approach, while the stepping stone method is visual, but they would have the same opportunity cost values or improvement indices. So for the unused cell with the cost of 11, the row position is still at row 1, where R sub 1 is equal to 0. The column position is now at column 3, where K sub 3 is equal to 2. Applying the formula, you have 11 minus the quantity 0 plus 2, or 11 minus 2 is positive 9. Next is the unused cell with a cost of 16. Row position is still at row 1 with a value of 0. Column position is at column 4 with a value of 1. Applying the formula, you have 16 minus the quantity 0 plus 1, or 16 minus 1 is positive 15. Next is the unused cell with a cost of 12. Row position is now at row 2, where R sub 2 is equal to 3. Column position is at column 1, where K sub 1 is equal to 8. Applying the formula, you have 12 minus the quantity 3 plus 8, or 12 minus 11 is positive 1. Next is the unused cell with a cost of 8. Row position is still at row 2 with a value of 3. Column position is at column 4 with a value of 1. Applying the formula, you have 8 minus the quantity 3 plus 1, which is equal to 8 minus 4, or positive 4. And finally, we have the last unused cell to evaluate, the one with a cost of 6. Row position this time is at row 3, where R sub 3 is equal to 6. Column position is at column 3, where K sub 3 is equal to 2. So applying the formula, you would have 6 minus the quantity, 6 plus 2, or 6 minus 8 is equal to negative 2. So we still have a negative opportunity cost value, and that was derived based on our analysis of the unused cell with a cost of 6. So with that, let's now proceed to the next steps. Step 7. Trace a closed path for the non-basic cell with the most negative C sub I sub j minus the quantity R sub I plus K sub j value. After which, assign plus or positive and minus or negative signs alternately at each corner square of the closed path, beginning with a plus sign at the non-basic cell that gave us the most negative C sub I sub j minus the quantity R sub I plus K sub j value. Then determine the smallest unit or shipment assigned to a U square in a negative position on the closed path of the non-basic cell with the most negative C sub I sub j minus the quantity R sub I plus K sub j value. And then add the determined unit or units to all squares in the closed path with positive signs and subtract from all squares with negative signs. Then go back to step 2 until you end up with a shipping pattern wherein all opportunity cost values are already positive. If you would notice, steps 7 to 10 are the same final steps that we had to do using the stepping stone method. So this should be familiar to you. Let's go back to our row minimum method. So based on our computation of your opportunity cost, we still had a negative opportunity cost, and that came from our analysis of the unused cell with a cost of 6. So let us now focus on that particular unused cell. Based on step 7, we now trace the closed path of that unused cell, which would be the adjacent cells. So from 6, you go left to 10, go up to 7, go right to 5, and then go back to our unused cell with a cost of 6. After which, we now assign our alternating symbols, beginning with the positive symbol on the unused cell that gave us the negative opportunity cost. So you have plus, minus, plus, minus. Then we now go to step 8. We now isolate those cells in our closed path where we have assigned the negative symbols and choose which one contains the minimum number of shipping units assigned to it. So between 30 and 40, the lower value is the value 30. Then we now go to step 9, wherein we now follow the symbols we have assigned to the corners of your closed path and apply the value 30. So for the unused cell that has a cost of 6, in the next tableau, that cell would now contain the value 30. In the used cell with a cost of 5, originally it contains 40 shipping units, but it has been assigned with a minus or a negative sign. So 40 minus 30, it would now contain 10 in the next tableau. For the used cell with a cost of 7, that would be 40 plus 30. Therefore, that cell would now contain 70 in the next tableau. And for the used cell with a cost of 10, it contains the value 30, which is what we have been adding and subtracting. Therefore, in the next tableau, that cell would become blank in order for us to maintain the m plus n minus 1 rule requirement. So this is now the transition from the first tableau to the second tableau. Again, for the unused cell with a cost of 6, it now contains the value 30. For the used cell with a cost of 5, it now contains the value 10. For the used cell with a cost of 7, it now contains the value 70. And for the used cell with a cost of 10, it is now blank. Let's now analyze our second tableau. So we again repeat the entire process, beginning with the assignment of the row and column indicators to each row and to each column. After which, we focus our attention to each used cell and apply the formula R sub I plus K sub j equal to C sub I sub j. Again, I would be using left to right, top to bottom direction. Beginning with the used cell with a cost of 8, row position is at row 1, column position is at column 1. Applying the pattern, you would have r sub 1 plus k sub 1 equal to 8. Next, use cell, the one with the cost of 7. Row position is at row 2. Column position is at column 2. Applying the pattern, you would have r sub 2 plus k sub 2 equal to 7. Next, use cell, the one with the cost of 5. Row position is still at row 2. Column position is now at column 3. Applying the pattern, you have r sub 2 plus k sub 3 equal to 5. Next, use cell, the one with the cost of 14. Row position is now at row 3. Column position is at column 1. Applying the pattern, you would have r sub 3 plus k sub 1 equal to 14. Next, use cell, the one with the cost of 6. Row position is still at row 3. Column position is now at column 3. Applying the pattern, you would have r sub 3 plus k sub 3 equal to 6. And then we have the last use cell, the one with the cost of 7. Row position is still at row 3. Column position is now at column 4. The resulting equation would be r sub 3 plus k sub 4 equal to 7. After which, we now determine the values of our row and column indicators by first assuming a value of 0 for r sub 1, and then performing the algebraic process of back substitution. If r sub 1 is equal to 0 for the first equation to be true, then k sub 1 should be equal to 8. If k sub 1 is equal to 8 for the fourth equation to be true, then r sub 3 should be equal to 6. If r sub 3 is equal to 6 for the fifth equation to be true, then k sub 3 should be equal to 0. Again, if r sub 3 is equal to 6, then for the sixth equation to be true, k sub 4 should be equal to 1. Earlier, we found the value k sub 3 is equal to 0. So if k sub 3 is equal to 0 for the third equation to be true, your r sub 2 should be equal to 5. And if r sub 2 is equal to 5 for the second equation to be true, your k sub 2 should be equal to 2. So again, the values of your row and column indicators are dependent on the equations that you got using your step number 3. So those values can be positive, negative, or 0. So after you have determined the values of your row and column indicators, just write them down on your tableau and then shift your focus to your unused cells. This time applying the formula C sub I sub j minus the quantity R sub I plus K sub j equal to your opportunity cost. Let's begin with a unused cell with a cost of 9. Row position is at row 1 with a value of 0. Column position is at column 2 with a value of 2. Applying the formula, you would have 9 minus the quantity 0 plus 2, or 9 minus 2 is positive 7. Next is the unused cell with a cost of 11. Row position is still at row 1 with a value of 0. Column position is at column 3 also with a value of 0. Therefore, the resulting opportunity cost would be positive 11. Next is the unused cell with a cost of 16. Row position is still at row 1 with a value of 0. Column position is at column 4 with a value of 1. So you would have 16 minus the quantity 0 plus 1, or 16 minus 1 is positive 15. Next is the unused cell with a cost of 12. Row position is at row 2 where r sub 2 is equal to 5. Column position is at column 1 where k sub 1 is equal to 8. Applying the formula, you would have 12 minus the quantity 5 plus 8, or 12 minus 13 is negative 1. Next is the unused cell with a cost of 8. Row position is still at row 2 where r sub 2 is equal to 5. Column position is at column 4 where k sub 4 is equal to 1. So you would have 8 minus the quantity 5 plus 1, or 8 minus 6 is positive 2. And finally, we have the last unused cell to evaluate for this tableau, and that is the one with the cost of 10. Row position is at row 3 where r sub 3 is equal to 6. Column position is at column 2 where k sub 2 is equal to 2. So that would be 10 minus 6 plus 2, or 10 minus 8 is positive 2. So looking at our opportunity cost values, we still have a negative opportunity cost, and that came from our analysis of the unused cell with the cost of 12. So let us now focus our attention on that particular unused cell. and then trace its closed path. So from 12, you go right to 5, down to 6, left to 14, and then back to our 12. After which, we assign our alternating symbols, beginning with the positive symbol on the new cell that gave us the negative opportunity cost. So you have there the plus, and then minus, plus, minus. After which, we isolate those cells in our closed path where we have assigned the negative symbols, and choose which one contains the minimum number of shipping units assigned to it. So between 40 and 10, we choose the value 10. And then we apply such value to the corners of our closed path following the symbols that we have assigned. So in the next tableau, the unused cell with the cost of 12 would now have a value of 10. The used cell with the cost of 14 would be 40 minus 10, or 30. The used cell with the cost of 6 would be 30 plus 10, or 40. And the used cell with the cost of 5 would now become blank, considering that it currently contains the value that we've been adding and subtracting. So this is now the transition from the second tableau to the third tableau. Again, the unused cell with the cost of 12 from the previous tableau now contains the value 10. The used cell with the cost of 14 from the previous tableau now contains a value of 30. The used cell with the cost of 6 from the previous tableau, it contains 30. It now contains the value 40. And the used cell with the cost of 5 would now become blank. If you would notice, this pattern is already the same optimal pattern we got using your stepping stone method. So let us see whether this is also going to be the final tableau for the use of the modified distribution method. So let's repeat the process. We now assign our row and column indicators to each row and to each column. Then we focus our attention to our used cells and follow the pattern R sub I plus K sub j equal to C sub I sub j. Beginning with the first used cell, the one with the cost of 8, found in the row of Cavite. Row position is at row 1, column position is at column 1. So the resulting equation would be R sub 1 plus K sub 1 equal to 8. Next is the used cell with the cost of 12. Row position is at row 2, column position is at column 1. So the resulting equation would be R sub 2 plus K sub 1 equal to 12. Next is the used cell with the cost of 7. Row position is still at row 2, column position is now at column 2. So the resulting equation would be R sub 2 plus K sub 2 equal to 7. Next is the used cell with the cost of 14. Row position is now at row 3, column position is at column 1. So the resulting equation would be R sub 3 plus K sub 1 equal to 14. Next is the used cell with the cost of 6. Row position is still at row 3 or R sub 3, and then column position is at column 3. So the resulting equation would be R sub 3 plus K sub 3 equal to 6. And then finally, we have the last used cell, the one with the cost of 7. Row position is still at row 3. Column position is now at column 4. So the resulting equation would be R sub 3 plus K sub 4 equal to 7. After which, we now proceed to determining the values of your row and column indicators by first assuming a value of 0 for R sub 1 and then performing the algebraic process of back substitution. So, if R sub 1 is equal to 0 for the first equation to be true, your K sub 1 should be equal to 8. If K sub 1 is equal to 8 for the second equation to be true, then R sub 2 should be equal to 4. If R sub 2 is equal to 4 for the third equation to be true, then K sub 2 should be equal to 3. If K sub 1 was found earlier to be equal to 8, for the fourth equation to be true, R sub 3 should be 6. If R sub 3 is equal to 6, for the fifth equation to be true, then K sub 3 should be equal to 0. Again, if R sub 3 is equal to 6, for the sixth equation to be true, then K sub 4 should be equal to 1. So after determining the values of your row and column indicators, we just write them down again on our tableau. After which, we shift our focus to your unused cells, and this time apply the formula C sub I sub j minus the quantity R sub I plus K sub j equal to your opportunity cost. Let's begin with the unused cell with the cost of 9. Row position is at row 1 where r sub 1 is equal to 0. Column position is at column 2 where k sub 2 is equal to 3. Applying the formula, you have 9 minus the quantity 0 plus 3, or 9 minus 3 is positive 6. Next, a new cell, the one with the cost of 11. Row position is still at row 1 with a value of 0. Column position is at column 3 with a value of 0 as well. So applying the formula, you have 11 minus the quantity 0 plus 0, or the result is positive 11. Next is the unused cell with the cost of 16. Row position is still at row 1 with a value of 0. Column position is now at column 4 with a value of 1. So you would have 16 minus the quantity 0 plus 1, or 16 minus 1 is positive 15. Next is the unused cell with the cost of 5. Row position this time is at row 2 where r sub 2 is equal to 4. Column position is at column 3 where k sub 3 is equal to 0. Applying the formula, you have 5 minus the quantity 4 plus 0, or 5 minus 4 is positive 1. Next is the unused cell with the cost of 8. Row position is still at row 2 where r sub 2 is equal to 4. Column position is now at column 4 where k sub 4 is equal to 1. Applying the formula, you would have 8 minus the quantity 4 plus 1, or 8 minus 5 is positive 3. And finally, we have the last unused cell to evaluate, the one with the cost of 10. The row position of which is at row 3 where r sub 3 is equal to 6. Column position is at column 2 where k sub 2 is equal to 3. Applying the formula, you would have 10 minus the quantity 6 plus 3, or 10 minus 9 is positive 1. So looking at our opportunity cost values, we don't have any more a negative opportunity cost. Therefore, we cannot anymore further reduce our cost, and therefore we stop the process at this stage. The last step would be, again, for you to recompute for the resulting total transportation cost based on the pattern that you have in your optimal tableau. And that can be computed by getting the sum of the product of the number of units assigned to a cell and its corresponding cost. So in this case, that would be 50 multiplied by 8, plus 10 multiplied by 12, plus 30 multiplied by 14, plus 70 multiplied by 7, plus 40 multiplied by 6, plus 50 multiplied by 7. And as I mentioned earlier, this pattern is already the same pattern we got using your stepping stone method. So this would also yield the same minimum transportation cost of 2020. This is your modified distribution method.